Hello, in this video we'll be looking at potential difference and the volt. We'll be looking at energy and we'll be looking at charge and how they're all related. Now let's start with a battery that I've drawn here. Now this battery has used chemical energy to create a potential difference. So I'm going to say the potential on the positive side is 12 volts, this is the positive side, and the negative side is 0 volts. What's really important is that the potential difference is 12 volts. Now, this potential difference could have been created by a power supply, positive and negative, 12 volts. Okay, so that was produced by chemical energy. That could have been produced via transformer from electrical energy, which came from a power station. But either way, they've created this potential difference of 12 volts. Now, if we are to let's make a circuit. Now, if we create a circuit here, and we're going to use conventional currents, the idea of conventional currents, there'll be positive to negative flow, so the flow is going to be in that direction. You will get a current to flow, and you'll find that the potential will drop from 12 on that side, it will drop down to 0 onto that side. Okay, now what you find is that you could think of it as energy per charge. So I think of voltage, volt, is equal energy divided by charge, or joules per coulomb. So that's energy divided by charge. This is the idea of this potential. Now, the definition of potential difference is this. The potential difference is equal to, so again, the idea of this, so you've got this energy, this charge has got a certain amount of energy, and when it goes through this component resistor here, what's going to happen here is you're going to get the majority of the potential drop across here, so 12 volts there, then it'll drop down to 0 volts there, assuming that there's no resistance in these wires. So what you're going to say is that you're converting electrical energy into other forms. So effectively in a resistor, you'll be converting it into heat. And the potential difference can be thought of as the, if you like, the electrical energy. Okay, that's what it has. Electrical energy converted into other forms. So in a resistor, it will be converted into heat, divided by the amount of charge passing. So the potential difference is all about the conversion of energy into other forms divided by charge. And the idea of this, the potential difference, or in volts, is equal to energy divided by charge, joules per coulomb. And that's the idea of a volt. A volt can be defined as the potential difference across a component is 1 volt when you convert 1 joule of energy moving 1 coulomb of charge through the component. So I shall write that down. Okay, so the volt. The potential difference across a component and in our case that was the resistor, is 1 volt when 1 joule of energy is converted when you have is converted moving 1 coulomb of charge. Okay, so if that much charge is flowing, the coulomb of charge is flowing, and that is converted to 1 joule of energy, then you have a potential difference of 1 volt. So if we go back to the original, what I read originally, so 12 volts would be 12 joules per coulomb. So if I had, if there was 1 coulomb of charge flowing, then 12 joules of energy is converted into other forms away from electrical.